Autophagy is like the ultimate multitasking custodian inside your cells, sweeping up damaged proteins, worn-out mitochondria, and other cellular debris, recycling them into components that can be reused for energy or repair. It's the microscopic version of a tidying guru, operating silently in the background while you sip coffee or scroll through social media. But here's where the morning paradox gets especially interesting. Autophagy is most active during fasting, yet breakfast interrupts this process. The moment nutrients enter your bloodstream, insulin rises, and TUR pathways light up, and the cellular cleaning crew is politely told to pause its work. Lysosomes sigh, proteasomes roll their tiny eyes, and AMPK mutters, "Great, now we have to wait while glucose takes center stage." The gut adds a whole new dimension to this paradox. Your gut microbiota, the trillions of bacteria, fungi, and other microbes that call your intestines home, are not just passive passengers. They respond dynamically to food intake, nutrient composition, and meal timing. During fasting, autophagy is active not just in host cells but also indirectly in gut epithelial cells, helping maintain the integrity of the intestinal lining and supporting barrier function. Fasted states allow certain beneficial bacteria to thrive, feeding off mucus and host-derived compounds, which can promote short-chain fatty acid production and anti-inflammatory signaling. In short, skipping breakfast or delaying it slightly gives your gut a quiet, uninterrupted window for cellular repair and microbial balance, with autophagy acting as the master conductor. When breakfast arrives, especially a carbohydrate-heavy meal, insulin spikes and autophagy pauses. The sudden influx of nutrients also changes the microbial environment. Bacteria that prefer glucose or starches rapidly engage in fermentation, producing byproducts like short-chain fatty acids, gases, and vitamins. While this is beneficial for digestion and energy, it temporarily shifts the gut from a repair and maintenance mode into an energy processing and growth mode. It's as if your gut bacteria are at a spa in the morning, relaxing and maintaining balance during fasting. But breakfast is the equivalent of a surprise party that makes everyone scramble, dance, and produce microbial confetti. The autophagy janitors inside the gut epithelium, responsible for recycling damaged organelles and regulating inflammation, put down their tiny brooms, while insulin and nutrient-sensing pathways redirect cellular focus toward digestion and nutrient uptake. The humorous scenario plays out beautifully at the microscopic level. Picture lysosomes in the gut epithelial cells sweeping diligently while AMPK waves a motivational flag. Let's keep cleaning. Barrier integrity is our priority. Suddenly, breakfast bursts in, led by insulin in a neon vest. Stop right there. Nutrients detected. Autophagy paused. Mitochondria cheer for the incoming glucose. Neurons in the enteric nervous system fire happily, and your gut bacteria begin their own disco party, metabolizing nutrients at full speed. Meanwhile, the autophagy team sighs and folds up their tiny tools, muttering, "We'll get back to it eventually." It's a microscopic sitcom, combining efficiency, chaos, and a touch of molecular comedy. Scientific research supports this nuanced interplay. Studies show that intermittent fasting or time-restricted eating promotes autophagy in gut epithelial cells, improves intestinal barrier function, and enhances microbial diversity. Conversely, the timing and composition of breakfast influence which microbial populations dominate, how much fermentation occurs, and how autophagy is temporarily modulated. The practical takeaway is that breakfast timing and composition can subtly shape both cellular recycling and gut microbiota dynamics. A nutrient-rich, lower-carb breakfast may gently wake up the gut and provide energy without fully derailing autophagy, whereas a high-sugar meal produces a more dramatic insulin spike and temporarily halts cellular cleanup in both host and microbial cells. From a functional perspective, this morning interplay allows the body to balance repair, microbial health, and immediate energy needs. Skipping breakfast or delaying it slightly can give autophagy a head start, enhancing gut epithelial maintenance, improving barrier integrity, and supporting beneficial microbial activity. Eating breakfast afterward provides fuel for both the host and the microbiota, ensuring cognitive function, muscle energy, and metabolic performance are optimized. The system is elegant, adaptive, and, even at a microscopic level, playful. Your lysosomes, mitochondria, gut bacteria, and neurons all coordinate a subtle dance of repair, energy processing, and signaling, often with a sense of timing that would impress even the most meticulous orchestra conductor. Ultimately, the breakfast autophagy gut health paradox illustrates just how clever and humorous human physiology can be. Autophagy prefers fasting and quiet, uninterrupted cleaning, promoting cellular repair and gut balance. Breakfast interrupts that session but fuels energy-demanding organs and gives gut microbes a lively wake-up call. Timing, composition, and personal context determine how this balance plays out, but either approach, fasting or eating, works beautifully when orchestrated thoughtfully. It's a microscopic comedy, a molecular ballet, and a health strategy rolled into one. Lysosomes grumbling, mitochondria cheering, bacteria dancing, and insulin occasionally bursting in with a clipboard, all perfectly coordinated to keep you alive, energetic, and maybe a little amused by your own cellular antics.